The Buran spacecraft, GRAU Index 11 F-35K-1 was a Soviet orbital vehicle analogous in function and design to the US Space Shuttle, developed by chief designer Gleb Lozino-Lozinskiy of RKK Energia. Buran completed one unmanned spaceflight in 1988 and remains the only Soviet reusable spacecraft to be launched into space. The Buran program was cancelled in 1993 following the dissolution of the USSR. It was treated as a Soviet space shuttle, but only the plane itself was theoretically reusable, and while it was recovered successfully after its first orbital flight, it was never reused. The expendable Energia rocket served as its launch vehicle. The flown Buran spacecraft was destroyed in 2002 at the Baikonur Cosmodrome, when the hangar it was stored in collapsed. Overview. The Buran orbital vehicle program was developed in response to the US Space Shuttle program, which in the 1980s raised considerable concerns among the Soviet military and especially Defense Minister Dmitry Ustinov. An authoritative chronicler of the Soviet and later Russian space programs, the academic Boris Chertok, recounts how the program came into being. According to Chertok, after the US developed its space shuttle program, the Soviet military became suspicious that it could be used for military purposes, due to its enormous payload, several times that of previous U.S. launch vehicles. The Soviet government asked the TSNIMASH for an expert opinion. Institute director, Yuri Moshrin, recalls that for a long time the institute could not envisage a civilian payload large enough to require a vehicle of that capacity. Officially, the Buran spacecraft was designed for the delivery to orbit and return to Earth of spacecraft, cosmonauts, and supplies. Both Chertok and Gleb Lozino-Lozinskiy suggest that from the beginning, the program was military in nature. However, the exact military capabilities, or intended capabilities, of the Buran program remain classified. Commenting on the discontinuation of the program in his interview to New Scientist, Russian cosmonaut Oleg Kotov confirms their accounts. Like its American counterpart, the Buran, when in transit from its landing sites back to the launch complex, was transported on the back of a large jet aeroplane, the Antonov An-225 rear transport aircraft, which was designed in part for this task and remains the largest aircraft in the world to fly multiple times. According to a May 1990 declassified CIA report citing open-source intelligence material, the software for the Buran spacecraft was written in the Prolog programming language. Flight into space. The only orbital launch of Buran occurred at 3 o'clock UTC on November 15, 1988 from Baikonur Cosmodrome Site 110/37. It was lifted into orbit, on an unmanned mission, by the specially designed Energia rocket. Unlike the NASA shuttle, which was propelled by a combination of solid boosters and the shuttle's own liquid fuel engines fueled from a large fuel tank, the Energia Buran system used thrust from the rocket's 4RD-170 liquid oxygen kerosene engines developed by Valentin Glushko and another 4RD-0120 liquid oxygen liquid hydrogen engines. Even though the program was delayed by several years, Buran was the first space shuttle to perform an unmanned flight, including landing in fully automatic mode. The Buran automated launch sequence performed as specified, and the Energia rocket lifted the vehicle into a temporary orbit before the orbiter separated as programmed. After boosting itself to a higher orbit and completing 2 revolutions around the Earth, ODU engines fired automatically to begin the descent into the atmosphere. Exactly 206 minutes into the mission, the Buran orbiter landed, having lost only 8 of its 38,000 thermal tiles over the course of the flight. The automated landing took place on a runway at Baikonur Cosmodrome where, despite a lateral wind speed of 61.2 km per hour, it landed only 3 meters laterally and 10 meters longitudinally from the target mark. Specifically, as Buran approached Baikonur Cosmodrome and started landing, spacecraft sensors detected the strong crosswind and the robotic systems sent the huge machine for another rectangular traffic pattern approach, successfully landing the spacecraft on a second try. Projected flights and related development. In 1989, it was projected that Buran would have an unmanned second flight by 1993, with a duration of 15–20 days. Because the project was cancelled after the dissolution of the Soviet Union, this never took place. several scientists looked into trying to revive the Buran program, especially after the Space Shuttle Columbia disaster. Discussions of a Russian successor. In 2010, the director of Moscow's Central Machine Building Institute said the Buran project would be reviewed in the hope of restarting a similar manned spacecraft design, with rocket test launches as soon as 2015. Russia also continues work on the PPTS but has abandoned the Kuiper program, due to differences in vision with its European partners. In late 2013, on the 25th anniversary of Buran, a new Super Heavy Lift launch vehicle was announced for development by Roscosmos. Destruction. On May 12, 2002, a hangar housing Buran collapsed during a massive storm in Kazakhstan, as a result of poor maintenance. The collapse killed 8 workers and destroyed the craft as well as a mock-up of an Energia carrier rocket. Commemoration activities. On the 25th anniversary of the Buran flight in November 2013, Oleg Ostapenko, the new head of Roscosmos, the Russian Federal Space Agency, proposed that a new heavy-lift launch vehicle be built for the Russian space program. The rocket would be intended to place a payload of 100 tons in a baseline low Earth orbit and is projected to be based on the Angra launch vehicle technology. Preserved shuttles. A Buran space shuttle prototype, which never flew to space, can be seen at Gorky Park, Moscow, Russia. A Buran space shuttle prototype, which never flew to space, can be seen at Technik Museum Speyer, in Speyer, Germany. This version has 4 turbojet engines which provided enough thrust for the shuttle to make atmospheric test flights. See also: Mikhail Gurevich MiG-105, a Euro-Soviet orbital spaceplane, N1, spaceplane, spacecraft, reverse engineering, references. Further reading: Energia Buran, the Soviet Space Shuttle, Bart Hendrik and Bert Vista, Springer Praxis, 2007, ppA 526, ISBN 978-0-387-69848-9. Heinz Elser, Margaret Elser Haft, Vadim Lukashevich, Buran, a Euro History and Transportation of the Russian Space Shuttle OKGLI to the Technik Museum Speyer, 2 languages, German and English, 2008, ISBN 3-9809437-7-1, external links.